Hi, hello, welcome to all. This is Bhasker. We are discussing 5th chapter quadratic equations from 10th class mathematics.
Let's discuss the next problem from exercise 5.3. The sixth problem. The diagonal of a rectangular field is 60 meters more than the shorter side. If the longer side is 30 meters more than the shorter side, find the sides of the field. So what is given? The diagonal of a rectangular field is 60 meters more than the shorter side. So here the diagonal of a rectangular field, how it is? It is 60 meters more when it is compared with the shorter side of the rectangular field. So what is the shorter side in rectangular? It is breadth. So that means here the diagonal is 60 meters more than the width of the rectangle, and if the longer side is 30 meters more than the shorter side, so here the longer side means length of the rectangle, and how it is? It is 30 meters more than the shorter side means width. So here the diagonal of the rectangular field and length of the rectangular field, both of these compared with the shorter side, that is width. So these two informations we have, and we need to find the sides of the field. So here sides of the field means the field is in rectangular shape, so that's why we have to find the length and breadth of this rectangular field. So let us see how to find this. So let us see the solution of this problem. So here the diagonal of this rectangular field is 60 meters more than the shorter side. So shorter side means that is breadth. So here the diagonal is dependent on the width, and the longer side, that is length is also dependent on breadth. So here diagonal and the length both are dependent on the shorter side, that is breadth. So we have to assume the shorter side or breadth with a variable. So here I am assuming breadth with x meters. Using this variable x, now we can able to know the values of diagonal of this rectangular field and length of this rectangular field. So here it is given that the diagonal of rectangular field is 60 meters more than the width. So to know the length of the diagonal, we need to add 60 to the length of the breadth. So then the diagonal will be x plus 60 meters. So why it is x plus 60 meters? Since the diagonal is 60 meters more than the length of the breadth. So that's why we have to add 60 to the breadth, so that we get the value of diagonal. And in the similar way, length of the rectangular field will be how much? Clearly it is given that the longer side is 30 meters more than the shorter side. So for the shorter side means width. For the width we have to add 30 meters. So we get x plus 30 as the length of the rectangular field. So now we have length of the rectangular field and the diagonal of the rectangular field and width of the rectangular field with respect to x. Now we need to able to establish a relationship between these three. So to establish the relationships, let us see the figure first. So here the field is in rectangle shape. So let us take a rectangle box here, and in this rectangular box let us take one of its diagonal. So in rectangle we know that the diagonal's lengths are equal. So this is the diagonal, and this diagonal length is how much it is? With our assumption we have x plus 60 meters. So this is x plus 60, and the length of this rectangle is x plus 30, and width it is x meters. So now if you observe this triangle, in rectangle every angle is 90 degrees. So this triangle will be a right angle triangle, and this diagonal is a hypotenuse for this right angle triangle, and these two are the remaining two sides. According to Pythagoras theorem, we can establish the relationship between these three sides. So what is Pythagoras theorem? In right angle triangle, the square of the hypotenuse is equals to the sum of the squares of the remaining two sides. So here what is hypotenuse? It is diagonal. So x plus 60 whole square should be equals to the squares of the sum of the squares of the remaining two sides, that are length and width. So here in one side plus we can take x plus 30 and its square. Next x square. Now let us simplify this. It is in the form of a plus b whole square. By using a plus b whole square formula, we can write it as a square as x square plus b square as 60 square. 60 square is nothing but 6 square 36 and 60 square is 3600. A square plus b square plus 2ab. So 2ab means 2 into x into 60. So here 2 into 60 we get 120. So we get 120x, and the same a plus b whole square formula can also be applied for this also. So by using that one, we get a square as x square, b square as 30 square means 900, and 2ab, 2 into x into 30, 2 30 is a 60, 60x we get, and plus x square. And if you see here, this is the x square with positive sign, and here also we have the x square with positive sign. So these two terms are equal and have the same sign, so that we can eliminate these two terms from both sides. And next, let us transpose these two terms to this side. So here we left with 0, and here write the first highest degree term, that is x square. Next plus 60x, and here we have the like term of this 60x as 120x. So by transposing this to this side, we get minus 120x, and next we have plus 900, and the next constant term, that's plus 3600. By transposing, it will become minus 3600. Now again simplifying this, we get x square plus 60x minus 120x. So we have to subtract these two terms. So by subtracting, we get minus 60x, and by subtracting these two constant terms, we get 2700, minus 2700, which is equals to 0. So we can write this equation as x square minus 60x minus 2700, which is equals to 0. Now we get the quadratic equation, and we need to find the solution of this quadratic equation, that is x. So to find the solution of this equation, we may use any of the three methods, that are factorization method, or completing square method, or quadratic formula method. So use any one of these method and find the solution of x, so that we can able to know the width of this rectangular field, and using that we can find the length also. So do it on your own and find the solutions of this problem.